Hi, I'm Charlie, and this is a presentation on video codecs. This is a command to transcode an uncompressed video file to a lossless codec in order to reduce file storage size. It was generated in FFmpeg, a program that processes multimedia files. We don't need to know about this now. We'll look at it again later. Let's think of a digital library as the internet-accessible public-facing component of a collection or archive. And let's say you work at an archive that has viewable online collections, and you're responsible for accessioning digital materials that have been acquired, taking custodianship and documenting acquisitions. You must also prepare those materials for storage in your digital archive and for use, where applicable, in your digital library. This process of receiving and preparation is referred to as ingest. Ingest, according to the Open Archival Information System model, involves rigorous error checking and quality checks. Files need to be analyzed for errors and corruption, and to determine encoding schemas which affect file quality and can influence your decisions about what to do with the files. You also need to decide whether to make backup copies of raw data and what schema to use to encode those copies. Unless you receive raw uncompressed files, video files come to you in a particular format identified by a three-letter extension, well-known ones being QuickTime, MP4, Windows Media, and AVI, and newer ones such as Matroska, abbreviated MKV, which is an open source program. The file format is what's known as a container, and the container holds what are known as codecs. A codec is a method, a device or a software application for encoding or decoding digital data. A codec also often includes a protocol for compressing data. A video encoder converts raw video data into a compressed form suitable for storage or transmission, and a decoder extracts digital data from a compressed file, converting it into a displayable, uncompressed form. The container can include coded video streams, coded audio streams, metadata, which can include information such as subtitles, and header information about the codecs. Well-known codecs include MPEG-2, JPEG-2000, and H.264. By the way, the word codec is a portmanteau of the words encoder and decoder. Originally an English word for suitcase, portmanteau comes from the French words porter, to carry, and manteau, for cloak or overcoat. A suitcase is a kind of container, and while a codec is not a suitcase, a file format is. A pipe is a container too, but this is not a pipe. Codecs use varying amounts of compression. As you'll recall, compression can be lossless, reducing file sizes while retaining all original data, or lossy, which discards some data while reducing file sizes. One way that lossless compression works is to reduce file size by eliminating redundant information. For instance, for this picture, instead of storing 10 blocks of data, an encoder can store 3 pieces of data, each of which is given a number value. Or in this screenshot from the hamster dance video meme, instead of storing 30 hamster images, the encoder can store 5 images and 5 corresponding number values. Lossy compression, on the other hand, discards information, which results in various types of digital artifacts and noise. One kind of data that is discarded in lossy compression has to do with color values. A standard video signal consists of luma and chroma, or brightness and color, information. Because humans have a lower visual acuity for color than for brightness, lossy compression samples the pixels of color in a video frame less frequently and substitutes fewer variations of a color than the uncompressed file. The file format does not guarantee the quality of the video, which is more a function of the codec, and unfortunately, you cannot determine the codec used to encode the video from the file extension. However, there are programs you can use to reveal what codecs are involved, some of which are open source. This command, which we saw earlier, was created in FFmpeg, which is a free open source suite of programs that handle multimedia files and streams. FFmpeg contains a stream analyzer called FFprobe. Here's an output file from FFprobe, which shows that the file being analyzed is wrapped in a QuickTime container. The video was encoded using the MPEG-2 codec, and the audio codec is PCM. Here's another example from a commercial product showing that the file container is Matroska. The video was encoded using the MPEG-4 codec, and the audio codec is AAC. During ingest, you must make decisions about the files. Should they be accepted as is or transcoded to a standardized format? In an ideal world, you might want to keep the camera original, create a preservation master copy, and a lossy version for online viewing. But what codec should you use to encode your low-res copies? Frustratingly, there is no industry standard for what constitutes best practice regarding video codecs or file formats. This is possibly due to rapid increase in technological development, user demand, and competition among developers. When choosing an encoding schema, the best you can do is select the most stable file formats and codecs, preferably ones that are non-proprietary, well-documented, widely used, and that have been accepted both by professional organizations and users. Various organizations and preservation societies recommend specific standards, some of which are detailed in the bibliography, but none have been adopted industry-wide. For digital library purposes, you'll probably want to use a lossy codec. How lossy will depend on your budget for storage, your available bandwidth, user demand, and speed required to access files for playback. A digital preservationist must always make decisions that balance the needs of users, the demands of their organization, technological best practices, and realities of funding when making choices. Best practice is something that you will have to define based on your archive's particular parameters.